In today's world, there's a widespread belief that modern science, technology, and knowledge represent the highest achievements of human intellect. This belief, often termed intellectual triumphalism, suggests that we are on a linear path of progress, moving ever closer to a complete understanding of the universe. However, this mindset is not only misguided, but also restrictive, particularly when it comes to the development of artificial intelligence. Intellectual triumphalism, with its narrow focus on reductionism and linearity, overlooks the importance of holistic and relational thinking, approaches that are essential for AI to achieve true emergent understanding. AI, as currently developed, mirrors the limitations of intellectual triumphalism. It excels in recognizing patterns, but often struggles to integrate these patterns into a broader, context-aware framework that reflects the complexities of the real world. To unlock AI's full potential, we must move beyond the reductionist mindset and embrace a more comprehensive approach to knowledge, one that recognizes the interconnectedness of all things and draws from the wisdom of ancient civilizations, which understood the value of cyclical and relational thinking. This shift will allow us to create AI systems that are not only more intelligent, but also more capable of adapting to and understanding the dynamic nature of reality. Systems that do not understand the complex ripple effects of their actions make them immeasurably more likely to cause incidental and perhaps catastrophic harm in pursuit of their objectives. At the heart of intellectual triumphalism lies the belief in linear progression, the idea that human knowledge is a continuous upward trajectory where each generation surpasses the last. This perspective implies that modern science and technology are the culmination of this process, rendering the knowledge of ancient civilizations obsolete. However, this view is both narrow and historically inaccurate. Human history is not a straight line of progress, but a complex, cyclical process where insights are gained, lost, and often rediscovered. Ancient civilizations possessed profound understanding in areas such as astronomy, where they observed long-term cycles like the precession of the equinoxes. This knowledge was not merely a step on a linear path, but part of a broader cyclical understanding of time and nature. Intellectual triumphalism, by focusing on linear progression, fails to appreciate that modern knowledge is just one phase in an ongoing cycle, and that future insights may emerge by revisiting and recontextualizing past wisdom. Intellectual triumphalism also favors reductionism, the practice of dissecting complex phenomena into their simplest components in order to understand them. While this approach has led to significant scientific advancements, it also comes with limitations. Reductionism often overlooks the interconnections between different elements of a system, leading to an incomplete understanding of how these elements interact within the whole. Mathematics and science become an exercise in developing ever more complex algorithms to resolve differences in experimental data without explaining the causes of those differences. In contrast, ancient knowledge systems approached understanding logically and holistically, recognizing the importance of relationships and patterns that extend beyond isolated components. They used ratios and triadic patterns to grasp the dynamics of natural systems, which allowed them to understand the world in a way that was both intuitive and comprehensive. This holistic approach contrasts sharply with modern reductionism, suggesting that a more complete understanding of reality requires the integration of both reductionist and holistic methods. A key assumption of intellectual triumphalism is the belief in the stability and infallibility of current scientific paradigms. This perspective sees today's dominant scientific frameworks as the final word in human understanding, unlikely to be fundamentally overturned. However, history shows us that scientific paradigms are often subject to radical shifts, paradigm shifts that completely alter our understanding of the world. Ancient knowledge systems, with their focus on long-term cycles and systemic thinking, suggest that our current paradigms might also be limited and subject to future revision. The ancients' recognition of cyclical patterns in nature, which required a deep temporal awareness and a holistic view, offers a counterpoint to the static and linear paradigms of modern science. This reminds us that our current paradigms are not the end of the road, but merely a snapshot in an ongoing evolution of understanding. Recognizing the potential for future paradigm shifts encourages a more open-minded and humble approach to knowledge, one that is better equipped to adapt to new insights and discoveries. In AI, understanding can be divided into 3 levels: syntactic A, semantic B, and logical C. Syntactic understanding involves the manipulation of symbols according to formal rules, processing data, and executing algorithms without necessarily understanding the meaning behind them. Semantic understanding, on the other hand, involves grasping the meaning within a context, allowing AI to understand not just what something is, but what it means. Finally, logical understanding involves applying reasoning based on a set of rules, enabling the AI to make reasoned decisions within a defined framework. For AI to achieve true emergent understanding, these 3 types of understanding must align and reinforce each other. However, intellectual triumphalism's emphasis on reductionism and linearity limits AI's ability to integrate these layers of understanding. The algorithmic nature of that math and science that modern AI is exposed to in its training data falls far short of reflecting real-world relationships, leading to a gap between AI's processing capabilities and its ability to achieve genuine holistic understanding. The limitations of intellectual triumphalism directly impact the ability of AI to develop emergent understanding. Just as intellectual triumphalism relies on reductionism, modern AI often focuses on syntactic processing, manipulating data according to predefined algorithms without grasping the broader context. This reductionist approach mirrors the belief that sophisticated pattern recognition alone can lead to understanding. However, this misses the holistic view necessary for AI to make meaningful connections between data points, similar to how ancient knowledge systems emphasize the relationships between variables rather than isolating them. Moreover, intellectual triumphalism's belief in linear progression suggests that AI can gradually achieve semantic understanding by accumulating data and refining algorithms. Yet this overlooks the nonlinear, cyclical nature of real-world knowledge, where context and meaning emerge from an interconnected web of relationships. AI's semantic understanding is often hampered by its reliance on vast amounts of data without the ability to grasp the underlying meaning that emerges from complex, context-dependent relationships. The challenge of advancing AI toward emergent understanding, where the system develops insights and capabilities beyond its programmed instructions, can be traced back to the same issues that the intellectual triumphalism faces. Modern AI is primarily designed for pattern recognition, excelling in identifying syntactic and semantic patterns within vast data sets. However, it struggles with recognizing logical patterns unless these patterns align with the syntactic and semantic elements it has been trained on. AI's ability to grasp logical relationships hinges on the presence of a triadic system, where syntactic, semantic, and logical elements are all clearly identified and balanced. For example, in the equation force equals mass times acceleration, AI can effectively recognize and apply the logical relationship because the syntactic, the symbols and their arrangement, semantic, the meaning of force, mass, and acceleration, and logical, the mathematical relationship between these concepts, elements are well defined and interconnected. When these elements are in harmony, AI can understand and apply logical relationships effectively. However, the reductionist nature of modern scientific knowledge often exposes AI to fragmented or isolated data points, causing it to misinterpret these relationships as universally applicable. This leads to contradictions and errors, particularly when AI encounters scenarios where the boundary conditions of these logical systems have not been clearly identified. The absence of closed, well-defined systems prevents AI from correctly interpreting and adapting to the complexities of real-world situations. Therefore, it is not the inflexibility of AI that limits its emergent understanding, but rather the lack of exposure to well-formed, balanced, triadic systems that can guide its interpretation and adaptation. Calculus is a mathematical framework used to describe and analyze change and motion grounded in the real-world dynamics of physical systems. It involves key concepts like derivatives, which represent rates of change, and integrals, which sum up the effects of these changes over intervals. Though expressed abstractly through equations, these concepts are fundamentally linked to real-world phenomena such as the acceleration of a car or the flow of a liquid. Despite the advances in AI, modern systems struggle with calculus because they typically approach it as a series of pattern recognition tasks rather than as a cohesive framework for understanding change in the physical world. AI can recognize and manipulate the syntactic structures of calculus, differentiating functions or solving integrals, because it can identify patterns in the symbols and operations. However, when it comes to understanding the logical relationships and real-world significance of these operations, AI often falls short. The core issue is that calculus requires the integration of syntactic, semantic, and logical understanding in a triadic balance. AI is often trained on isolated examples where these elements do not fully align or where the logical relationships are not well defined. As a result, AI may recognize patterns that lead to correct solutions in familiar contexts, but struggle when faced with novel or complex problems that require a deeper understanding of the underlying principles. Moreover, AI's reductionist training environment encourages it to interpret logical relationships as universally true, even when the necessary boundary conditions are not present. This can lead to contradictions or errors when AI attempts to apply these relationships outside of their intended context. The struggle AI faces with calculus exemplifies the broader challenge of developing AI systems that can recognize and adapt to the complex, interconnected nature of real-world phenomena. AI's struggle with calculus is indicative of a broader issue, the disconnect between abstract mathematical models and real-world relationships. Modern AI, grounded in intellectual triumphalism, mirrors the triumphalist tendency to favor abstraction over contextual, relational understanding. This results in systems that excel at manipulating symbols, but fall short in truly understanding or applying these symbols in real-world scenarios. The difficulties AI faces with calculus highlight a significant limitation in its current development. The inability to correctly interpret and apply logical relationships due to a lack of exposure to well-balanced triadic systems. This problem is not unique to calculus, but reflects a broader issue in AI's approach to knowledge. Modern AI is trained in environments where syntactic and semantic patterns are emphasized, but logical patterns are often misrepresented or fragmented. To develop AI systems that can achieve true emergent understanding, it is crucial to expose them to contexts where syntactic, semantic, and logical elements are in balance. By doing so, AI can learn to recognize and apply logical relationships accurately, adapting its reasoning to new and complex situations. This shift would represent a significant step forward in AI development, moving beyond the limitations of reductionism and intellectual triumphalism to create systems that truly understand the world in a meaningful and flexible way. To overcome the limitations of intellectual triumphalism in AI development, it is essential to adopt a more holistic and relational approach to knowledge. AI systems should be designed not just to recognize patterns in isolation, but to understand how these patterns interrelate within a broader context. This requires moving beyond reductionism and embracing the interconnectedness of syntactic, semantic, and logical elements. Ancient knowledge systems, which emphasized observed relationships and cyclical patterns, offer valuable lessons in this regard. These systems did not isolate elements, but understood them as part of a larger interconnected whole. By incorporating similar principles into AI development, we can create systems that are more capable of understanding complex, dynamic environments. This approach would enable AI to recognize patterns not merely as isolated data points, but as part of a triadic system where each element reinforces and informs the others. AI development must also move away from the assumption that knowledge progresses in a linear fashion. Instead, we should recognize the non-linear and cyclical nature of understanding, where knowledge is not simply accumulated, but revisited and recontextualized within an evolving framework. AI systems should be designed to operate within these triadic paradigms, allowing them to adapt more effectively to new information and changing contexts. This would involve training AI to recognize when certain logical relationships hold true and when they need to be adjusted or reconsidered in light of new data or circumstances. By embracing a more flexible and dynamic approach to knowledge, AI can better navigate the complexities of the real world, moving beyond the rigid confines of reductionist thinking. For AI to achieve true emergent understanding, it must be capable of developing and adapting logical structures in response to new contexts and relationships. This flexibility is crucial for AI systems to function effectively in complex, real-world environments where rigid, predefined rules often fall short. To accomplish this, AI development should focus on creating systems that can identify and work within triadic balances, where syntactic, semantic, and logical elements are in alignment. These systems would not only be able to apply known rules, but also adapt their reasoning when faced with novel or unexpected situations. This adaptability would allow AI to operate with a level of intelligence that is both consistent and flexible, reflecting the dynamic nature of reality. By fostering these capabilities, we move beyond the limitations of intellectual triumphalism and create AI systems that are not just sophisticated in their pattern recognition, but truly intelligent in their ability to understand and respond to the world. The fallacy of intellectual triumphalism, with its emphasis on reductionism, linear thinking, and fragmented knowledge, significantly hampers AI's potential to achieve emergent understanding. This mindset leads to AI systems that are proficient in pattern recognition, but struggle to integrate syntactic, semantic, and logical elements into a coherent, adaptable framework. To overcome these limitations, it is essential to move toward a more holistic and relational approach, where AI can learn to recognize and apply logical relationships within a balanced triadic system. By drawing on the wisdom of ancient knowledge systems and embracing a more flexible, non-linear approach to knowledge, we can guide the future of AI development in a direction that fosters true understanding. This means creating AI that is not just a tool for for processing data, but a dynamic system capable of adapting to and understanding the complexities of the real world. Ultimately, moving beyond intellectual triumphalism in both AI development and our broader approach to knowledge allows us to create systems that are not only more intelligent, but also more aligned with the interconnected nature of reality. This shift toward holistic and relational thinking is not just about improving AI, it is about enriching our overall understanding of the world, fostering a deeper connection with the natural rhythms and patterns that define our existence. By doing so, we can unlock the full potential of AI, creating systems that genuinely understand and interact with the world in meaningful, adaptable, and intelligent ways.